evidently I hit the mark when I was in the middle of this. So what I did is just find out the grams of magnesium per mole. And then you go like this, and you'd be like, oh, for every mole of magnesium, one way to do it. There's other ways to move. This is the way it makes sense to me. I should have elicited 461.96 kilojoules. And if you were only measuring a joule, a smaller amount of joules, you might want to go ahead and take, just make sure, let's do it now. For every kilojoule, there are 1,000 joules. So make sure that if you have, for your specific capacity, if you use joules or calories, that's consistent. So there, you should be able to, whatever you get for this answer here, find a percent error. So let's just say I have no clue what this is. No clue whatsoever. No clue. It's completely made up. But say that you got 240 joules. And then from your trial, I'm using Q equals MCAT, you got 300 joules. To find the percent error, so this would be from Q equals MCAT, from the calorimeter. So in order to figure that out, you would have to figure out the error. So you'd be like, what did I say, 290? 290 joules to 300. So it'd be like 290 minus 300 absolute value divided by the actual value on the bottom, which is what you got on paper. What you expected on paper, not what you measured in lab. This could be all sorts of crazy. So put the 300 on the bottom, and you should put that in a percentage. Okay. So since you're doing the average, I'm still trying to think. If you didn't keep your mass consistent, this is my bad. I never did a lab. If you just took different masses every time, then you're going to have to do different trials and then, average your error. Take each discrete one. So you found when it said to say, calculate ether formation, magnesium 2 for each trial and determine your average. Yeah, so that's, I don't know if it makes sense to do. This will be your experimental data. That should be where you use Q equals MCAT and then compare it to your calculated average to get your error. So if you have 3 different values, you have to do it 3 different times. Okay. Identify one error which could have resulted in a negative error, which means delta F is more positive than expected. That's from your experiment. So let's go real quick to 5 and tie this off. We got if the heat of formation calculated was more positive, then so the only thing here that whatever you got for Q equals MCAT, remember it's negative for that of the reaction. So that, make sure you add a negative here, because if it entered your calorimeter, it had to have exited your reaction. So if it's a little bit more positive, that means what? That means it's less negative, which means this value is too small, which means your change in temperature could have been too small. I think we can say that we found the mass accurately. Our specific heat is a constant. So what could cause your measured temperature difference to be too small? What could cause delta T to be too small? I'm going to let you answer that. I think it's a good thing to reflect. Hey, did I measure every single bit of temperature that was liberated in my calorimeter from the magnesium that was given off? Did I measure that? If not, why? Did your metal float a lot to the top and stick out of solution and come into contact with the air? If so, if it's hot, some of that could have left to the air molecules. There's one example. Did we have a lid? Did we have, whatever? You can talk about these things. So then it says to say, explain the role of the chloride ion in the experiment. It has no role. We call it a spectator ion. In fact, that's just what you should be able to pay special attention to. If it didn't change in the reaction, it's called a spectator ion. That means it really didn't matter if it was there or not. It didn't do anything. It didn't react. It's hanging out there. It's chilling, but it's not participating. Okay, so hopefully that's helpful. I'm going to post this and the last one and then get on to